6, 5, 4, 3, engine start. 1, 0, and liftoff of the Delta rocket carrying GLAST, a gamma-ray telescope searching for unseen physics in the stars of the galaxies.
GLAST stands for Gamma Ray Large Area Space Telescope, and it is an orbiting observatory designed to survey the entire sky every day and look at gamma ray radiation coming from sources in space. This will be effectively the Hubble Space Telescope of the high energy end of the electromagnetic spectrum. And every day we're going to take a picture of the entire sky. And we expect that every day that image will change with time because the sources that we're seeing will flare on and off, and we'll measure all the interesting properties that we observe with the gamma rays. So it's like a movie of the sky every day. So the best way to think of gamma rays is as particles of light with very high energy. If you want to visualize what the gamma ray sky looks like, if you could see it with your eyes, the sky you see at night with your eyes is not the best guide because it's fairly quiescent. There's not too much going on. You look out there and you see stars twinkling. If you looked in gamma rays, what you would see a bright band where the Milky Way galaxy is, but that band would be alive with sources that are flaring on and off. We first thought of doing this experiment in 1992 when the Egret experiment was in orbit, and we said, gee, we need something better. And so with a colleague of mine at SLAC named Bill Atwood, we thought of building this experiment, and that was in 1992.
And the big surprise in Egret was, nose under the camel's tent, Egret saw a gamma ray sky that nobody had even dreamed of. And it was a 4th of July fireworks show. Things were popping off and flaring, and gamma ray bursts were bursting, and pulsars were pulsing. And you know, if you could put on your gamma ray goggles and look at the night sky, it would be more like a fireworks show.
Many of the sources are in our own galaxy. They're things like neutron stars, which are gravitationally collapsed objects that are rapidly spinning and emit pulses of electromagnetic radiation as they spin. And studying the high energy radiation from these sources tells us a lot about the processes by which the particles that generate the radiation are accelerated in the environment of a neutron star. There are also objects that are black holes, the ultimate in a gravitationally collapsed object. And we expect to see literally perhaps 10,000 such sources outside our galaxy that are basically black holes that are lurking at the cores of what are called active galaxies. And in these sources, the radiation is generated in the vicinity of a very rapidly spinning black hole.
And especially when the galaxy is young and the inner portion of the galaxy is still replete with a lot of garbage, dust, stars, whatever. This black hole is in feeding mode, and it's accreting this matter into it. And during this accretion process, this stuff starts swirling around at great velocities. These things are beyond your imagination, both in size and ferocity.
And what we're seeing is the energy extraction from that spinning black hole, and it comes out in the form of gamma rays. So we expect to see literally thousands of those kinds of sources. The belief is that a rotating black hole that's in the vicinity, has a magnetic field nearby, will twist the magnetic field around in such a way that it generates a large electric field. And that electric field has such a strength that any charged particles that happen to wander in will be accelerated to close to the speed of light. So the most distant ones that we see are probably 10 billion light years from Earth. What that means is that when the gamma rays were emitted, from the time they were emitted to the time they arrive here at Earth, it took 10 billion years, traveling at the speed of light. So that's a sizable fraction of the size of the known universe.
Perhaps we'll even see that these objects extend to the edge of, namely high redshift, with enormous black holes, and there you run into a very interesting conundrum. The black hole was too big to have been made since the universe was born. A problem, and if that is the case, then some of these black holes, in fact, will be revealed as primordial. And that's the quest of all of this. Where did we all come from? What are the smoking guns? What are the clues, the relics left behind from the creation of everything?